By the end of this lesson, you should be able to define acceleration and deceleration and state that A equals V minus U over T. Calculate acceleration and deceleration. Have you ever watched a Formula One race? Observe the highlighted car. What can you deduce about its velocity? The car is moving faster and faster. The velocity of the car increases. The speedometer shows that the velocity of the car is increasing. The change of velocity over a time interval can be represented by a physical quantity called acceleration. Suppose the car accelerates from an initial velocity u to a final velocity v in time t. The acceleration of the car is... Acceleration is a vector quantity. The SI unit for acceleration is meter per second squared. Determine the acceleration of the car. We know that initial velocity u equals 60 kilometers per hour. Final velocity v equals 100 kilometers per hour. Time t equals 5 seconds. The acceleration of the car in SI unit is 2.22 meters per second squared. The driver brakes when approaching a junction, and finally the car stops. What can you say about the velocity of the car? The car is getting slower. Its velocity is decreasing. Suppose the car was moving with an initial velocity of 12 meters per second and takes 6 seconds to stop. Calculate its acceleration. We know that initial velocity u equals 12 meters per second. Final velocity v equals 0 meter per second. Time t equals 6 seconds. The acceleration of the car is -2 meters per second squared. A negative value here means that the car decelerates. We can say that either the car accelerates at -2 meters per second squared, or the car decelerates at 2 meters per second squared. A negative acceleration does not always mean that an object is slowing down. When the velocity and acceleration are in the same direction, the object moves faster. When the velocity and acceleration of the object are in the opposite direction, it slows down. An accelerating object can be observed through a trail of stroboscopic pictures. A snapshot of a moving car is taken at equal time intervals. The car moves to the right. The distance between images in the trail provides information on how fast the car moves in a certain time. Describe the motion of each car.
We can analyze linear motion in a laboratory using a ticker timer. A ticker tape is attached to a trolley on an inclined runway. When the trolley is released, a trail of dots is marked on the tape at equal time intervals. The trail of dots provides a history of the trolley's motion and is therefore a representation of the trolley's motion. The distance between dots is increasing over time. The velocity of the trolley is increasing. What can you say about velocity and acceleration of the trolley in each case? Click on the tape for a description of the motion.